This AI engineering roadmap takes you from core fundamentals to advanced AI implementations. It covers essential mathematics, machine learning, deep learning, and large language models, providing you with the exact skills needed to thrive as an AI engineer in 2025. Whether you're starting fresh or upgrading your skills, this roadmap offers a clear path to success with hands-on experience and industry-relevant insights. Tatev from Lunar Tech developed this course.
Imagine being at the forefront of one of the most transformative fields of our time, where technology meets innovation and changes the world. Welcome to the AI Engineering Roadmap of 2025. My name is Tatev Aslanyan from Lunar Tech, and I'm absolutely excited to be here with you today to dive into this highly requested topic. Together, we will explore everything that you need to know to navigate this exciting world of artificial intelligence and AI engineering to set yourself up for success in this field. In this video, we are going to break down the step-by-step roadmap for becoming a world-class AI engineer. Here is what we are going to cover. First, we will define what AI engineering is and how it fits into this broader ecosystem of AI and data science. Next, we will explore the real-world applications of AI engineering, showcasing its really strong power, transformative impact across different industries. Then we will dive into the must-have versus nice-to-have skills, helping you to understand exactly where to focus your efforts and your time. Finally, we will go to step-by-step process, so the skill sets that you need to master, outlining the essential topics to help you become a job-ready AI engineer. This session is packed with unique insights and practical tips that you won't find anywhere else, so stay tuned. Without further ado, let's get started. So let's start with the basics. What is AI engineering? AI engineering is this practice of designing, building, and deploying AI systems that solve real-world problems. It sits in this intersection of software engineering, machine learning, and data science. And here is how it fits into this broader tech world and the ecosystem. So the data scientists often focus on analyzing data or predicting something or developing models. AI engineers take these models and make them work in the real-world settings and with much more advanced models. They create systems that process data, make decisions, and deliver actionable insights. For example, in the healthcare, a data scientist might develop a machine learning model to detect the tumors in the X-rays. An AI engineer brings this to the next level. He ensures that the model is integrated into hospital systems, runs in real time, and works reliably under different conditions. Also, AI engineers, they work with much more advanced models like deep learning models or neural network-based models. So, data science principles, system design, optimization, machine learning, deep learning is what all combines into one place, which is AI engineering. It's not just about building models, it's about making sure that those models actually solve problems and deliver value for the business or this public enterprise. And that's why AI engineering is such a critical role in today's tech ecosystem. It's where this cutting-edge research meets the practical, industry, impactful implementation. So bridging this gap between the research and the actual engineering. So AI engineering isn't just limited to one field. It's changing industries all over the world. Let's look actually at some of the examples how AI engineering is making an impact. First up is the healthcare. So AI systems are used to analyze medical images, predict patients' outcomes, and also assist the doctors in the drug discovery or the patient care. AI engineers build these systems to ensure that those are scalable, reliable, and efficient for real-world use. Next up is the finance. From fraud detection to algorithmic trading, AI processes massive amounts of financial data in real time. Engineers in this field, they focus on creating secure, efficient, and real-time systems that can handle this sensitive information real-time, like fraud detection. In the retail and the e-commerce, in the platforms like Amazon, they use AI to personalize recommendations, optimize pricing, and manage inventory. AI engineers, they design algorithms and systems that drive these experiences. Next up is the entertainment. Of course, the streaming platforms like Netflix, they rely on AI for personalized content recommendations. Gen AI tools like DALL-E and ChatGPT are changing now how the creators produce content. Next up is the autonomous vehicles. So self-driving cars, they depend on AI for navigation, object detection, and decision-making. AI engineers, they are the ones who design these algorithms and the hardware integration to make these autonomous vehicle systems safe and reliable. So these examples are just few of them, and they show how different and impactful AI engineering is. So whether you are passionate about healthcare, finance, tech, defense, or any other creative industry, there is a place for you in this field. And that is actually why the AI engineering is so popular this day, and it's going to be one of the most in-demand professionals in the next decade. There are many industries and companies who are currently hiring. When it comes to the salaries for AI engineers, those are highly competitive. Just for the entry role, they start around 80 up to 120K at least. For the mid-level engineers, this is 120K to 180K in US. And for senior roles, this can take all the way from 200 up to 750K in the US dollars. So let's now get into the actual skill set that you must know in order to become an AI engineer. And here I'm talking about becoming a world-class, well-rounded, real AI engineer. Not just someone who does prompt engineering, real AI engineer. Not just someone who does prompt engineering and without knowing these different models, just uses them, but actually becomes someone who will create new algorithms, who will create their own unicorns, or will become an AI engineer. And without knowing these different models, just uses them, but actually becomes someone who will create new algorithms, who will create their own unicorns, or will become an AI engineer that works at this large cutting-edge companies like OpenAI, Tesla, Meta, and many other cutting-edge startups. So first up is, of course, the mathematics. Mathematics is a field when it comes to traditional machine learning all the way to the most cutting-edge AI that you see nowadays. So when it comes to mathematics, there are different topics from this field that you must know. Not the entire universe of mathematics or the super advanced stuff, but really the fundamentals. And these are selected topics from different levels. So you cannot just say first level of university or second level of university of that specific study. No, it's a combination of these different levels from these different fields and studies that you need to combine in one place, learn it, such that you can move on to the next stage. And today I will tell you which are those in more detail, such that you are left with specific topics for you in mind to learn mathematics if you decided to do a self-study and become a self-paced AI engineer on your own. So first up is the high school mathematics. In here, you can understand doing basic divisions, how to solve an equation with squared unknowns. So for example, x squared plus something, you are able to calculate the discriminant to find the solutions to that equation. You know these different geometric terms like what is sinus, what is cosine, what is tangent, what is cotangent, the Pythagorean theorem, basically all the topics from the high school, all the way to the last level. Next up is the linear algebra, of course. Linear algebra comes usually from the second year of econometric study or applied mathematical and statistical studies. And this field is really important for understanding not just the traditional machine learning, but also the deep learning, which is really important. And it's a more advanced type of ML that powers today's most cutting-edge applications, including the GPT models, the transformers, etc. So if you want to know and understand the cycle of neural networks, the training, how it's being optimized, and how this entire neural networks structure works, then you must understand linear algebra. So when it comes to linear algebra, let me tell you specifically what I mean. Not the entire linear algebra, but really to understand the norm of a vector, this understanding of vector and matrices, the Cartesian coordinate system that comes from the high school, but then here is also very relevant to understand where the vectors are, how you can position the vectors in the Cartesian coordinate system. Understand this idea of norm versus Euclidean distance, the Pythagorean theorem here again, the orthogonality. You also need to understand the vectors and operations, so foundations of the vector, the special vectors, unit vectors, and also the idea of dot product, the application of the dot product, the Cauchy-Squarce equation. Also, you need to understand the matrices and the solving of the linear systems using this idea of matrices. So here you need to have the foundations of linear systems and matrices. You need to be able to add matrices, multiply them to compute the dot product between matrices or between matrix and a vector. Also, understanding of Gaussian reduction, the reduced echelon form, the row reduced echelon form, the null space, the column space, the rank, the full rank. This all will be foundation for you to understand how these neural networks work. If you truly want to understand the different deep learning and AI models. You also need to have a good basis when it comes to linear transformation and matrices. So these algebraic laws for matrices, including how it actually works, how you can solve a system with linear equations, multiple of them using these different transformations. So what is, for example, the transpose of a matrix? What is the inverse of a matrix? And apply these different rows and the rules from linear algebra. Also, what is the determinant, how you can calculate it, what are the properties of determinant, the transpose of matrices, I believe I just mentioned. And then you also need to understand some topics from advanced linear algebra, like the projections of vectors, the Gram-Schmidt process, the infamous process that you need to understand, the matrix factorization, really important, not just for the deep learning, but also for the traditional machine learning, or the things like matrix factorization that is used in the recommender systems. So this part is also very important to understand the QR decomposition, eigenvalues, eigenvectors, which is really important for understanding the principal component analysis and dimensionality reduction. Also the eigen decomposition, which is based on eigenvalues and eigenvectors, and understand the singular value decomposition, or the SVD, which is really important part as part of traditional machine learning. So this is what you need to know when it comes to the linear algebra. And if you are looking for that one place to learn linear algebra, then last year we have published an entire 26+ hour course that covers all these topics in one place. It was quite a popular course and highly demanded one. And you can get also a certification once you complete it. So check out this course, the Fundamentals to Linear Algebra, at lunartech.ai to also go through all these topics, follow it, study it, practice it, and then get also a certification. Next up, when it comes to mathematics, beyond the linear algebra and the high school mathematics, you also need to understand calculus. This one is really important as well. You will need to have an understanding what are the gradients, what are the derivatives, how you can calculate derivatives, how you can calculate the integrals, not just with one, but with two variables, basically, so double integrals, how you can use this derivatives and the integrals when it comes to optimization, this concept of the slope and optimization of the models using the gradients, first order gradient and second order gradient in the context of it, how you can adjust the parameters for better accuracy, and just a traditional calculus 1 and some calculus 2. So this is a no-brainer when it comes to AI, not just for advanced AI, but for the traditional machine learning, for understanding these different models, you must know calculus. Next up is the game theory. Not the entire universe of game theory, not all the topics, but there are some topics from game theory which usually comes from third year of econometrical or applied mathematical studies is something that you must know. Think about Nash equilibrium or the min-max strategy or this game where competing is actually resulting in worse outcome than collaborating. So this idea of Nash equilibrium is really important for understanding one of the foundational generative AI models, which is the generative adversarial networks. So for understanding one of these Gen AI models, you will need to also have this couple of topics from game theory in place. All right, so that's about the mathematics. And here I'm also not mentioning this foundational geometry topics, which is usually also covered as part of high school. So once again, the sine, cosine, the tangent, how to work with the different angles, the 90-degree angle, what are these different values for different angles, and this common notation with the pi, so what the pi represents, the radians, etc. Once you're comfortable with these mathematical topics, the next topic that I would suggest you to study is the statistics. Statistics is very important when it comes to becoming a well-rounded AI professional. To understand the idea of predicting the next word, but all the way to the very basic machine learning, having these basics of statistics will be very helpful to you. So here is the list of topics that I would suggest you to study when it comes to statistics. So first up, of course, understanding this concept of probabilities. To know what the probabilities are, what is its concept, why it is used for this concept of probability distribution functions, the PDFs, the cumulative distribution functions, or the CDFs, and also to understand what is this idea of sample, why we use sample versus population, this idea of having a representative sample, work with the data. So understanding, for example, what are the random variables, what is this idea of experiment, what are the probabilities, the criteria and the qualities of probabilities, what is the PDF or the probability distribution function, what is the cumulative distribution function, this basic statistics like the mean, the median, the variance, the standard deviation, the mode, and also how they can be calculated, this idea of covariance and correlation, what is the difference between correlation and causation, understanding how these different statistics can be used to describe your data and to tell a story about your data. And also this idea of sample versus population, why we use sample, and why we are unable, for example, to deal with the population, and how this becomes relevant when it comes to this entire universe of data science. Also understanding the bias theorem, the different rules when it comes to the probabilities, like the conditional probability, the idea of independence between different random variables. Then get into some basic probability distribution functions, especially the normal distribution function, the Bernoulli distribution function, this idea of Bernoulli trials, the binomial distribution function, what is this connection between Bernoulli distribution function and the binomial distribution function, how it is used in these different concepts like tossing a coin. So basic statistics, basically. Also understand the idea of linear regression and ordinary least squares. What are these different conditions and assumptions that this ordinary least squares is making when calculating and optimizing these different parameter estimates? This idea of estimation versus the unknown parameters, the idea of error terms, the error terms versus residuals. And also this concept of Gauss-Markov theorem, how it is used, and this comes usually from econometrics, and the idea of parameters. What are the properties of parameters, like the bias of a parameter, the consistency, and the efficiency. And this is again tied back to the Gauss-Markov theorem. Also, the understanding of confidence interval will be really important in your career in the field of data science and AI. The idea of 95% confidence interval, how it's calculated, what is this idea of calculating this interval, the lower bound and the upper bound, what it means. Another very important topic from statistics is this idea of hypothesis testing. Why we need hypothesis testing, the idea of null hypothesis, the alternative hypothesis, how you set up these experiments, why it is important, why we even need it. The concept of statistical significance is very important. How to calculate type 1 error, type 2 error, what is the difference between them, what is false positive, what is false negative. The statistical tests like the student's t-test, the f-test, ANOVA tests, the two-sample t-test, the two-sample normal test. There are so many tests that can be studied in this field of statistics, but there are a couple of them that I selected, and I would also provide you the links to that, and you can also check them out, and I would highly suggest you to study them. Also, this concept of p-value is very essential. Also, this calculation of the p-value, how you can use it, how to interpret it, its limitations, and also this concept of inferential statistics. So laws like the central limit theorem, the law of large numbers, how it is used when it comes to this experiments. And this is tied back to the normal distribution function, one of the most infamous distribution function that you must know as an AI engineer. Next up, we have the dimensionality reduction techniques like the principal component analysis or the factor analysis, and you can also add here the canonical correlation analysis, so a CCA. So if you are looking for that one place that in an organized way can help you to refresh your memory or to study all this in one place, then you can also check out our Fundamentals to Statistics course, because we are covering there all these different topics, which is a prerequisite and it's a must for you to know before you get into the next level in your AI engineering journey. So once you are comfortable with the mathematics and statistics, you are ready to move on to the next step in your journey of becoming an AI engineer. The next skill set is the skills of data science. So as an AI engineer, you really need to have a good data science skills. Without good data and without understanding whether you even have a good data or not and applying your data science skills, any of other skills won't matter. Because it's this phrase that is really easy to remember. You can have a great AI model, but if you put a garbage in, you will get a garbage out. And that what you put into your AI model is your data. If your data is trashy, is a bad data, and sometimes you don't even know that you are dealing with bad data because you don't have the data science skills, then it doesn't matter how much effort or how much money you will put in your AI model, how much GPUs you will use, or how big your data will be. If your data quality is a bad one. To understand these data skills, you will need to have a data science skills. So what I mean by that? So when it comes to AI models, they like to work and they are performing good if they are dealing with clean data. Your AI models also need to use a meaningful data, a relevant one. And also as an AI engineer, you are responsible for the ethical side of your model. And for that, your data should be unbiased as well. So as an AI engineer, you will need to understand how to clean data, how to source data, how to collect it if you don't have an AI engineer next to you, and also how to pre-process data. And here I mean identifying the missing data in your database to understand what is the mechanism behind it. Is it missing at random? Is it missing not at random? Because this will then define whether you can impute the data, so you can fill in this missing data, what kind of techniques you can use to fill in this missing data, or maybe to drop it altogether. to understand whether you have anomalies in your data, outliers, how you can use statistical and other techniques to find these outliers in your data and to remove it or maybe adjust it. This concept of normalization, you will need to have a good understanding how you can filter your data, how you can group your data, tell a story about your data before you even get into the model development section, and how to split your data, to have the skills of following the cycle of a data preparation, data evaluation, and also using the data as an input for your model, whether it's a machine learning, deep learning, or an advanced generative AI model. Also, understanding how to visualize your data is really important. As a data scientist, you usually learn the exploratory data analysis and how you can use these different tools, including Python and simple libraries like Seaborn and Matplotlib, to visualize your data. And as a data science skill, this is a must to also identify outliers, to identify certain trends, and also to tell a story about your data. So this is basically the pre-work that you need before you get into any model development, if you want to do everything properly and as a professional. You also need to understand feature engineering skills, which also is a data science skill. So understanding how you can create new variables. So sometimes, for example, you have multiple variables, but it's not good enough because you just need one, and it's usually a combination of these multiple variables. And by understanding how you can combine different variables in your database in one place and create one single variable is what we are referring as a feature engineering. So you engineer the features that then you can use as an input to your machine learning or your deep learning or your AI model in general. So this is about the data science. Knowing data science will set you for success when it comes to AI engineering career. Next up is the infamous traditional machine learning. So without understanding traditional machine learning, there is no way to become a well-rounded AI engineer. If you don't want to be in this position where for every single problem you use neural networks, you waste your company's money on the GPUs, or you spend a lot of time on using complex models that while you can use a simple machine learning models, if you don't understand this, then you can never become this AI engineer that looks at problems not just from a research perspective, but also from business or enterprise perspective. So that's why I always suggest to first master the traditional machine learning and then only get into the next point. So here, what I mean by traditional machine learning. I mean to understand this concept of classification, regression, supervised learning, unsupervised learning, these different algorithms that fall under these categories like linear regression, logistic regression, decision trees, bagging, boosting, XGBoost, light GBM, GBM, and many other models, including unsupervised models like K-means, hierarchy clustering, or DB-scan, in which cases, which of your models you can use. The idea is that once a PM or a business leader comes to you and tells you this vague business problem, you as an AI engineer, you will need to quickly be able to figure out whether you are dealing with a classification problem, regression problem, maybe an unsupervised learning problem. And you will also need to have this quick understanding, okay, I'm going to use most likely these models in order to solve that problem. And being able to understand this will be really important before you move on to any advanced model studying. So beyond understanding the algorithms, and if I remember correctly, those are about 23 or 24 algorithms from traditional machine learning, understand their mathematics behind it, statistics behind it, what are their benefits, what are their disadvantages, because in each of these categories, you also need to understand how each of these models work and have this understanding that for this type of problems, for example, when you have a lot of missing data, you can use that model because it's more stable. Or if you are dealing with a data that follows normal distribution, then you can better use another type of model. because for each of these classification, regression, or other type of problems, you will have many options, and it's up to you as an AI engineer to shortlist them and also from there to filter out which one you will use. So beside this, you will also need to understand how you can evaluate a traditional machine learning model. What is this common cycle of the training, testing, validation? What are these different sampling techniques or resampling techniques? What is bootstrapping? What is cross-validation? What is k-fold cross-validation or leave one out cross-validation? And also to understand what are the different evaluation metrics depending on your problem you can use in order to evaluate your model. For example, what is the difference between using the mean absolute error versus the mean squared error? In which cases you can use which one? Or the root mean squared error? Or how you can evaluate a model that is in the field of classification. It is the F1 score, or it's the F beta score, which is more general version of the F1 score. Should you use recall? Should you pay more attention to the precision, etc.? So understanding also when to use machine learning, when to use just rule-based approach will be also important for you as an AI engineer. So that is about machine learning. If you want to master the field of machine learning and everything that I just mentioned in one place, you can also check out our Fundamentals to Machine Learning course, where we cover everything that you must know in order to become a well-rounded machine learning specialist. You can also get a certification from Lunatech once you complete your machine learning course. So once you are comfortable with mathematics, statistics, and the traditional machine learning, next up is studying the deep learning. Deep learning is at the heart of the modern artificial intelligence, especially when it comes to generative AI. So all these different cutting-edge tools like the ChatGPT, the DALL-E, Sora, or the different applications, the self-driving cars, the robots, human-like robots, they are all based on neural networks. And neural networks is this fundamental part when it comes to deep learning. Think of the deep learning as a more advanced machine learning, where the models are able to study better with a larger amount of data. And this big data that the size of which increased more and more in the last decade made the evolution of the deep learning more possible. So when it comes to the deep learning, what I mean exactly is that you need to understand how the deep learning differs from the traditional machine learning. You need to understand the architecture of neural networks, and how it works, the concept of neurons, the perceptor, this in a simple way to be able to understand the structure of neural networks, the activation functions, what it means, this difference between different activation functions, and also understand in which cases to use what, this idea of hidden layers, input layer, output layer, how they are related to the performance of a neural network. You also need to understand the concept of forward pass, backward pass, the idea of backpropagation, what the backpropagation algorithm does, the idea of loss function, how you can calculate the loss function for a neural network. Also, how the training of neural network works. So how it starts from the input, then it goes to the forward pass, then does the loss calculation, the backpropagation, etc. And also, what is this idea behind it, and how making each of these different decisions like the activation function or the different optimization algorithms, how it will be impacting the performance of your deep learning model. Also understanding these different optimization algorithms like the gradient descent, stochastic gradient descent, the RMS probe, the momentum, SGD, etc. And of course, the ADAM or the ADAM-W, these different algorithms will be really important for you to understand how the deep learning models are being trained and optimized. Beside that, you also need to understand the concept of vanishing gradient problem, the exploring gradient problem, also understand these different computational graphs that are being used in order to represent neural networks. Also, how you can evaluate the performance of neural networks, how you can use the cross entropy, and being able to understand these different optimization techniques. The concept of mini batch gradient descent is also important, and the difference between batch gradient descent, mini batch gradient descent, stochastic gradient descent. Understand the concept of Haitian, why Haitian is being used, what it means to have a faster versus better performing neural network. Understand also this batch normalization, layer normalization, what is the difference between them. Understand the concept of residual connections, and also what is gradient clipping, caviar initialization, basically how you can initialize your neural network models. Of course, when I meant the fundamentals of neural networks, I definitely meant also understanding what is the bias, what is the weights, what it means to train a neural network, the role of improving these weights. And also you need to understand the ways you can solve these different problems, like how to solve a vanishing gradient problem, how to solve an exploding gradient problem. And also these different techniques to combat the overfitting, what it means to have an overfitting. This comes from traditional machine learning, but also in the deep learning, it's still a problem. And also understand how you can use dropout. What is dropout? What is this difference between random forest versus dropout? What is the L1 regularization, L2 regularization versus dropout? The difference between them. What is this idea of curse of dimensionality? And what is this difference between discriminative versus the generative models? What are autoencoders? What is this idea of reconstruction error? The nonlinear counterpart of PCA, basically, when it comes to autoencoders. Understand the architecture behind these different sorts of deep learning models, the infamous ANNs, CNNs, RNNs, GNNs, GRUs, LSTMs. What is the difference between the LSTM and the RNNs? Why they have been created? What are their problems? What are their good points? And also how you can train these different algorithms and for what kind of problems you can use. What is paired convolution? What is pooling? What is stride? When it comes to computer vision, and in which cases you can use what, where you can use RNN, where you can use CNN, and also the generative adversarial network. So we are getting more towards the generative AI, but I will tell you in a bit about that. So this is basically about the theory when it comes to deep learning, everything that I just mentioned. And having these fundamentals in place will be really important for you in order to go on to the next step, which is understanding how you can use the traditional machine learning and traditional deep learning in the real case problems, which means learning Python and learning advanced Python. The AI frameworks like the PyTorch and TensorFlow, but not just that, also to understand basic data structures and algorithms in Python, and beyond the Python for data science, also to understand how you can train a machine learning model in Python, how you can train a deep learning model in Python, how you can do a visualization in Python, or how you can filter your data, prepare your data, clean it. Basically, everything where it comes to data science, machine learning, and deep learning, its practical implementation is happening in a programming language. And that's where the Python, one of the most popular programming languages, come in handy. And my suggestion would be to learn next the Python, to understand how you can create lists, variables, how you can load data, different sorts of data, whether those are images, text, audio, how to work with dates, how to filter your data, how to group your data, how to visualize it, training a machine learning model, training deep learning model, how to make use of PyTorch, which is a deep learning framework in Python, as well as TensorFlow, this idea of tensors, and how you can build, you can train and deploy machine learning and deep learning model using Python. If you are looking for that one place to learn all what I just described, make sure to check the lunartech.ai page because we have an entire course when it comes to Python for data science, which would be a great starting point for you to learn Python specifically for AI and data science and also get a certification in that field. And if you want to check out all these different topics in one place when it comes to deep learning, make sure to check our deep learning interview preparation course, which covers all these topics that I just mentioned in a unique Q&A way. All right, so once you have done that, you have your mathematics, statistics, machine learning, deep learning, and Python, as well as advanced Python in one place, you are ready to move on to the next step. And here, of course, I'm talking about the generative AI. So when it comes to generative AI, this, by the way, also includes the large language models. Here is what I would suggest you to learn in order to call yourself a world-class AI engineer. Generative AI is one of the most in-demand skill set when it comes to the 2024 and 2025. In this AI race, in the companies like OpenAI, the Anthropic, Google, Meta, Tesla, XAI, all these different companies that are at the forefront of AI revolution, they all are based on these different usages of generative AI. ChatGPT is based on generative AI, the DALL-E is based on generative AI, and the Gemini, the Perplexity, the autonomous cars. These days, all of the cutting-edge AI tools in one way or the other are based on generative AI. That's why if you are an AI engineer with a specialization in generative AI, this will be your year. All right, so let's now talk about what exactly it takes to become a generative AI-based AI engineer. So first up, you need to understand the AI foundations and you need to understand where you can apply generative AI before you get into the theoretical part. So understanding also the model development cycle when it comes to generative AI and the training techniques will be really important because different type of generative AI foundation models can be trained and optimized in different ways. Understanding different foundational generative AI models will also be very important. Think of like the generative adversarial networks, this concept of the G and the D. So basically the generator, discriminator, what are their roles, what they are doing, how the game theory comes here in place, the where you can apply generative adversarial networks, the mathematics and statistics behind it, the min-max theory, the Nash equilibrium, and also this concept of mode collapse, which is a problem for generative adversarial networks, and how you can train and optimize these gens in order to create new data, for example, synthetic data, etc. So next topic that I would highly suggest you to study is this variational autoencoders. This is yet another foundational generative AI model that I would suggest you to study to understand its mathematics behind it, its statistics behind it, the idea of this difference between plain autoencoders and variational autoencoders, which is a matter of difference between discriminative and generative type of models, architecture behind it, the KL divergence, the elbow, how you can train a variational autoencoder, this all the way to the idea of reparameterization trick, and how you can apply a variational autoencoder in practice, of course. Next topic that I would suggest you to study is, of course, the transformers. So transformers, they are the mother of all the current cutting-edge large language models. When you hear about Llama from Meta, when you hear about GPTs from OpenAI, or the Cloud Sonnet from Anthropic, all these different large language models, at the base of them is the transformers. Transformers are at the heart of large language models, and knowing their history, their evolution, understanding what is the difference between transformers versus the RNNs and LSTMs from deep learning, understanding what was the reason of them being invented compared to the RNNs and LSTMs, the idea of embeddings, the positional encodings, how you can calculate them, the attention mechanism, the self-attention mechanism, the queries, keys, and values, the single-head attention, multi-head attention, understanding this entire architecture of transformers step by step, the mathematics and statistics behind it, how you can calculate these different parts, how you go from the input embeddings, positional encodings, all the way to the logits, which are the outputs of the transformers, will be really important for you as an innovator to understand, because then you will be able to understand this more variated versions of the transformers, because GPT models from OpenAI, which power the ChatGPT, for example, are a variation of transformer model. And given that these modern models like Llama, the GPTs or other ones, they are never published in its entirety. So you won't know, for example, what is the real architecture of GPT 403, which some call it also the first AGI model. For that, I would highly suggest you to go to the basics and to instead understand the transformers. Once you understand the transformers, you also understand the cycle of pre-training. So what it means to pre-train a transformer model, do it by hand from scratch instead of just using PyTorch library. This will help you to completely understand this foundational language model. Once you are done with your transformers, I would highly suggest you to get into the next topic, which is the large language models. When it comes to large language models, this is yet entirely a different universe. And for understanding this and calling yourself an expert in LLMs, you have quite a journey to go through. But I will make your life a bit easier, and I will give you the step-by-step process and the specific skill set that you can learn in order to master the field of large language models. So you can start with understanding what are the language models, this idea of n-grams, the concept of predicting the next word, and then how these large language models have been evolved over time. What is their unique sides, also understand what are the key large language models, like I just mentioned, the GPTs from OpenAI, the Llama from Meta, the Falcon, the Bird from Google, and also the Gemma from Google, the Cloud Sonnet from Anthropic. These are different very popular open-sourced or closed-source large language models that you can use as part of your AI engineering journey. And understanding these differences, understanding how it relates back to the transformer models will be foundational for you. Also understand this concept of open source and closed source. What are these different tools that you can use when it comes to open source? Of course, I'm referring to the Hugging Face and other platforms that you can use in order to use large language models and generative AI in a more efficient and cost efficient way. So understanding the foundations of large language models will be really important for you, like the attention mechanisms that I just mentioned, the language models, the n-grams, the architecture transformers, the type of architectures you will meet in the field of LLMs, like the encoder-based or decoder-based or a combination of them. The concept of tokenization from NLP, the embeddings, how you can calculate each of these parts of the transformers. If you want to be someone who understands these large language models, you want to know how to tweak them, how to edit them, and also in an intelligent way to use them in your job or create a platform. So you also need to be aware how you can prepare your data for your large language model application. Like with the machine learning or deep learning, if you don't have the data science skills, then it's just a matter of wasting your time and money, because then this concept of garbage in and garbage out still holds. Even if you have the most cutting-edge LLM model in front of you, if you don't know how to clean your data, how to deal with unstructured data, how to prepare it, and then ingest it into this AI model, then this AI model will be performing poorly. That's why understanding this prompt templates, these different type of models, these different structures will be paramount for you. Next up, I would suggest you understand the cycle of pre-training large language model, fine-tuning a large language model, prompt engineering, reinforcement learning, evaluating and optimizing it. So understand what it means to pre-train a large language model. How do those large companies use masked language modeling or autoregressive language modeling in order to pre-train a large language model? And then maybe do an example. Do a pre-training from scratch in order to get a taste of what it's like to pre-train a large language model. What are these different scaling laws? What is the output of pre-trained large language model? And what are these different downstream tasks that you need to be familiar when it comes to large language models? Because large language models can be used for classification. It can be for predicting a next word, for different tasks, instruction-based approach. For each of them, the downstream tasks is different, which means that the model and the way the model is trained is also different. And also, when it comes to the large language models, you need to definitely know how to fine-tune a large language model. So fine-tuning on a single task, fine-tuning on a multitask instruction model, how to perform parameter-efficient fine-tuning or the PEFT. And here, of course, I'm talking about understanding in detail the mathematics, the linear algebra behind LoRa, the CLoRa, so the quantized version of LoRa, how to prepare your data for fine-tuning, what are the steps behind fine-tuning, what is reinforcement learning, so unsupervised fine-tuning, supervised fine-tuning, and definitely also experience when it comes to fine-tuning. Can you, for example, fine-tune a large language model on your own? Do you know how to use these different models, etc.? Once you are done with the pre-training and fine-tuning, I would also suggest you to understand and learn this idea of reinforcement learning with human feedback. Not too detailed. You can start with the basics just to understand this concept of the RLHF, or the reinforcement learning with human capital. And why is that we use this? In order to make our models smarter. Then once you are done with that, I would highly suggest you also to understand this prompt engineering. So what it's like to work with language model and to make it smarter once it's already pre-trained and fine-tuned. In here, I would suggest you to look into the best practices for prompt engineering, how to do effective prompting, prompt optimization, and also how you can apply prompt engineering along with the fine-tuning in order to create AI agents. Once you are done with that, I would suggest you next to go into the topics over X. So to understand what are the concepts of the retrieval-augmented generators and systems, the vector databases, integrated RAGs with Gen AI, how to fine-tune with retrieved data, this concept of llama index, agentic RAGs, etc. So once you are done with this, I would suggest as a final last two topics for you. The first one is the evaluation and optimization of large language models, the mastering of the LLMs, to understand how you can use quantization, knowledge distillation, pruning, how you can use LLM ops to not just train LLM, but also productionalize it using topics like tools like LangChain, Flask, etc. And also understand how you can evaluate a large language model. There are different benchmarks, different data sets that you can use in order to properly evaluate and compare a specific large language model to other world-known universal large language models. So finally, I would say as an AI engineer, you are the first person responsible for the ethical and safe creation and usage of your AI models. That's why we all have a joint responsibility to understand the AI ethics, the principle of ethical AI, the bias in AI, the privacy and data security in AI, to understand this AI Act from Europe, to understand the GDPR Act, and then understand the regulations and the governance. So I hope this didn't overwhelm you. If you have a good guidance and if you have everything in one place, it will take on average 3 to 6 months for you, depending on where you are and whether you already have the prerequisites in order to become a world-class AI engineer. So AI engineering is all about solving real problems, not just the theoretical knowledge. being able to understand all the theory, the foundation knowledge, along with the implementation of each of these different topics in the reality will be really important for you to become a job-ready professional, a world-class 10x AI engineer who knows the foundations and the actual implementation by bridging the gap between research and the industry application. For that, you will need a well-rounded, comprehensive training as on one hand, and also on the other hand, the practical implementation with projects with a ready resume to be able to start applying or create your own startup. Because it's all about innovation in this field. And it takes a lot of effort and motivation to combine this different skill set in one place. But this also comes with a reward. On one hand, yes, you need to put a lot of effort in order to become an AI engineer, but on the other hand, this is one of the most rewarding and most in-demand careers for the next decade. So if you are serious about becoming a world-class AI engineer, then you can also apply to our AI engineering bootcamp at Lunar Tech to get everything in one place, not just surface level knowledge, but the theory, the actual projects that you can also put on your resume. Those are cutting edge projects. And as a result, you will be able to call yourself a real AI engineer and land that dream job, or to become a founder for a unicorn.